Something ancient just happened above us. The sun, that majestic fireball we take for granted, has reversed its magnetic field. North is now south, and with that we've entered solar maximum, a chaotic phase known for storms, flares, blackouts, and breathtaking auroras. Some believe these cycles are random. Others say they follow a deeper cosmic pattern, one that could explain forgotten ice ages, technological meltdowns, and even mass extinctions. Today we uncover what's really happening as our star flips the rules of space itself. On May 1st, 2024, something began to stir on the surface of the Sun. A dark blemish appeared on its eastern edge, a sunspot. At first it seemed ordinary, one of the many that come and go during the Sun's natural cycle. But within days, it grew and grew until it reached a size over 17 times larger than Earth. Scientists named it Active Region 3664, a title that now sends shivers through the space weather community. Soon after, it began erupting, hurling massive waves of energy toward Earth. These were no ordinary flares. They triggered auroras so bright they painted the skies red and green over cities that had never seen them before, from Scandinavia to Germany, even down to southern US states. Then NASA made a chilling confirmation. This was the most intense geomagnetic storm in nearly 500 years. And here's the most astonishing part. This event wasn't random. It was a signal that the Sun has reached its most volatile phase, the moment scientists call solar maximum, a phase that begins with a magnetic flip and ends with chaos, beauty, and danger, not just in the sky, but down here on Earth. The Sun may look calm from here, a glowing golden constant in our sky, but up close, it's a boiling sea of fire and magnetism, and every 11 years, it enters a kind of stormy adolescence. This phase is called the solar maximum, and we've just entered it. At the heart of this cycle is something that sounds almost impossible. The Sun's magnetic field completely flips. Imagine a planet-sized magnet stretching across the entire Sun, suddenly reversing its poles. North becomes south, south becomes north, and with that flip, everything changes. The flip doesn't happen overnight, it builds up quietly over years. Invisible forces beneath the Sun's surface begin to twist and tangle. The magnetic field becomes unstable, like ropes pulled too tight. Eventually, it snaps, unravels, and flips. And that's when the Sun gets loud. Sunspots begin to appear in dark, cooler regions where magnetic energy punches through the surface. But don't let the word cooler fool you. These sunspots are monsters, many times the size of Earth, and they're full of raw, explosive energy. Wherever a sunspot appears, chaos tends to follow. Solar flares, bursts of X-ray radiation, coronal mass ejections, massive clouds of charged particles hurled into space, all of it aimed at who knows where. Sometimes toward the emptiness of space, but sometimes directly at us. During solar maximum, these events become common, even weekly. The Sun becomes unpredictable, volatile, almost alive, and every pulse it sends across the solar system is a reminder that we're living in the path of a very active star. This is why scientists monitor sunspot counts so closely. It's like watching a heartbeat, and right now, the Sun's heart is racing. Back in the late 1700s, early astronomers began observing mysterious dark patches on the Sun's surface. They didn't know what they were, only that they appeared in clusters, then faded, then returned again, almost like the Sun was breathing. These were sunspots, and over time a strange pattern emerged. The number of sunspots didn't rise and fall randomly. They followed a cycle, building to a peak, then declining into silence every 11 years. This was the beginning of our understanding of the solar cycle, the heartbeat of our star. But sometimes, the heartbeat slows down, way down. The Maunder minimum, silence from the Sun. Between 1645 and 1715, something eerie happened. Sunspots vanished for 70 years. The sun went quiet. Only about 50 spots were recorded in that entire time, when thousands are normally seen in a single cycle. This period is now called the Maunder Minimum, and it didn't go unnoticed on Earth. The climate turned. Temperatures dropped. The Little Ice Age began. In Europe, rivers that never froze, like the Thames in London, turned to ice. Winters became brutal, crops failed, and famine swept across parts of the world. Was it coincidence or consequence? Could the sun's silence have triggered this global cooling? And if so, what happens when the sun grows louder than ever? The Dalton Minimum, a second chill. About a century later, the sun quieted again. Between 1790 and 1830, solar activity dipped, marking the Dalton Minimum. It wasn't as extreme as the Maunder event, but it still brought colder temperatures and chaos. In 1816, after a major volcanic eruption and low solar activity, the world experienced the year without a summer. Snow fell in June. Crops died in the fields. People went hungry across Europe and North America. The modern surprise, solar cycle 24 and 25. Fast forward to recent history. Solar cycle 24, which began in 2008, was anemic. Low sunspot numbers, few solar storms. Scientists wondered, is the sun heading into another grand minimum? But then, something unexpected happened. In December 2019, solar cycle 25 began quietly. Predictions said it would be even weaker than the last. But by 2024, that forecast was shattered. Sunspot numbers exploded, reaching levels not seen in 2 decades, and the cycle peaked early, catching experts off guard. We weren't heading into a solar minimum. We were accelerating into a maximum one that could rival the most intense on record. Throughout history, Earth has been struck not by asteroids, but by the invisible fury of the sun. And when it happens, the effects ripple through the skies, through technology, and into everyday life, often without warning. Let's go back to the year 1859. The Carrington event, the day the sky caught fire. On September 1st, British astronomer Richard Carrington was observing the sun through a telescope when he witnessed something extraordinary, a sudden, blinding flash of light erupting from a sunspot. He had no idea what he was seeing because no one had ever seen it before. Just 17 hours later, all across the Earth, strange things began to happen. Telegraph systems, the backbone of global communication at the time, began to fail. Sparks flew from the machines. Some operators were shocked. Others discovered their equipment still worked even when unplugged. The Earth itself had become electrified. And then, the skies lit up. Auroras appeared, not just near the poles, but as far south as the Caribbean. They were so bright, people could read newspapers outdoors at midnight. 1921, the New York Railway Storm. In May 1921, another violent solar storm struck Earth. There were no satellites yet, but there were railways, telegraphs, and early electrical systems. In Brewster, New York, a telegraph station caught fire. Railroad signals failed across the northeastern U.S. Communication systems were disrupted for days. If a storm like that hit today, with all our ultra-connected digital world, it wouldn't just burn out cables. It could black out cities, crash satellites, cripple navigation systems, destroy power grids. 1972, the mystery of the exploding mines. Between the Apollo 16 and 17 missions to the Moon, in August 1972, another intense solar storm struck Earth. It was strong enough to trigger underwater mines off the coast of Vietnam, causing unexplained explosions that baffled military intelligence at the time. And had astronauts been in space during that eruption, they would have been exposed to lethal radiation. the mission would have ended in tragedy. 1989, the Quebec blackout. In March 1989, the Sun struck again. A coronal mass ejection hit Earth, causing a massive geomagnetic storm. Within 90 seconds, the power grid in Quebec, Canada, collapsed. 6 million people were left in darkness for over 9 hours. Radio signals dropped. Satellites wobbled in orbit. And across North America, transformers overheated and some even melted. 2022, the Starlink incident. Most recently, in early 2022, SpaceX launched a batch of 49 Starlink satellites. But shortly after reaching orbit, a solar storm hit. The geomagnetic disturbance increased atmospheric drag, and 40 satellites were lost, tumbling back into Earth's atmosphere and burning up. A single burst of solar energy erased millions of dollars of technology in a matter of hours. Now, with the Sun entering solar maximum, storms like these may become more frequent and more intense. The question isn't if another Carrington-level event will happen, it's when. And this time, we rely on systems far more delicate than the telegraphs of the 1800s. Satellites, GPS, air traffic, internet, power grids, even the phone in your pocket. All of it exposed. It's a question whispered in online forums, debated in science classrooms, and even echoed in political halls. Is the Sun to blame for global warming? At first glance, it sounds plausible. The Sun is a massive ball of fire radiating unimaginable energy. So if it becomes more active, wouldn't that heat up Earth? Especially now, during solar maximum, when sunspots, flares, and magnetic chaos are at their peak. It feels like the pieces fit. But here's where the mystery unravels. Yes, the Sun's energy output does fluctuate during its 11-year cycle. At solar maximum, we receive slightly more solar radiation, a small uptick in what's called total solar irradiance. But here's the key word: slightly. The increase is less than 0.1%, not nearly enough to explain the dramatic rise in global temperatures we've seen over the past century. In fact, if we chart the Sun's activity since the 1950s, something strange happens. The Sun's energy has remained flat. No significant increase, no runaway spike, just the usual up, down, predictably. Now compare that to Earth's average temperature over the same period. It's been climbing steadily and sharply, far beyond what solar cycles can account for. Solar activity can impact short-term climate patterns. It's been linked to regional temperature dips, shifts in the jet stream, and as we've seen in history, possibly even contributing to long winters during solar minimums. But what's heating our world today is a different kind of force, one coming from within, not above. Because during high solar activity, it's not just temperature we need to worry about. It's power grid, satellites, communication systems, and the delicate balance of a civilization increasingly woven into electromagnetic threads. We've always looked to the stars as a symbol of possibility, but we rarely stop to think about how dangerous the journey really is. Because out there, in the silence beyond Earth's atmosphere, our machines, our signals, even our astronauts are exposed, and there's no greater threat than a storm from the Sun. During solar maximum, the Sun becomes a minefield of magnetic eruptions, solar flares, radio bursts, and coronal mass ejections. These aren't just beautiful fireworks. They're high-energy assaults that can travel through space at millions of kilometers per hour. When they reach Earth, most of the damage is absorbed by our magnetic field. But satellites, space stations, deep space stations, they don't have that kind of protection. Orbiting satellites, the invisible infrastructure behind GPS, telecommunications, weather forecasting, and even banking are extremely vulnerable during periods of high solar activity. Charged particles can fry circuits, scramble software, and even knock them out of orbit by increasing atmospheric drag. This isn't theoretical. In 2022, as we saw earlier, a relatively mild geomagnetic storm caused 4 newly launched Starlink satellites to fall back to Earth, burning up in the atmosphere. Billions of dollars gone in hours. And that was just a glancing blow. What happens when a full-force CME hits while hundreds of satellites are mid-operation? The risks don't stop at machines. They extend to people. Astronauts aboard the International Space Station live with constant solar radiation exposure, shielded only by thin layers of metal and timing. If a major flare were to erupt without warning, it could deliver radiation doses far beyond safe levels. That's why agencies like NASA and ESA carefully plan deep space missions like the Artemis program to the Moon around solar weather windows. A poorly timed launch could leave astronauts flying directly into a solar storm, and in deep space, there is no shelter. The Artemis guidelines are clear: no launches during high solar activity, no exceptions. It's a harsh reminder that no matter how far we reach, we are still at the mercy of our star. But here's a twist in the tale. During solar maximum, as the sun becomes more active, its magnetic field actually strengthens. This stronger field extends into the solar system and acts as a shield against cosmic rays and high-energy particles that come from outside the galaxy. Cosmic rays are harder to block than solar radiation and cause slow, long-term damage to satellites and spacecraft electronics. So, ironically, when the sun is angriest, it may also be protecting us from something even worse. They're called the lights of the gods, ribbons of color that dance across the sky in silence. Green, red, purple, like waves from another world. But what causes them is nothing short of a cosmic collision. It starts with a storm, not on Earth, but on the Sun. When a coronal mass ejection explodes from the Sun's surface, it sends billions of tons of charged particles hurtling through space at incredible speeds. If that wave slams into Earth's magnetic field, something extraordinary happens. Our planet's magnetic shield deflects most of it like invisible armor. But at the north and south poles, that shield bends and opens. Through these gateways, solar particles funnel into the atmosphere where they collide with oxygen and nitrogen high above our heads. And when they do, they ignite the sky. Green auroras appear when particles hit oxygen around 100 to 300 kilometers above Earth. Red auroras, rarer and more haunting, happen even higher at 300 to 400 kilometers and must be 10 times brighter to be seen. In May 2024, these red auroras were visible over Germany, New York, and even Texas, a sign of just how powerful that solar storm was. The sky itself became a canvas, painted by the breath of a star. The best places to witness them? Canada, Alaska, Norway, Iceland, Finland, Tasmania. But during solar maximum, they might just come to you. So the next time you see the night sky shimmer, remember, you're watching a battle between Earth and Sun turned into art. Above us, 150 million kilometers away, the sun burns, ancient, unstoppable, alive. It gives us light, warmth, and life itself. But it's not as stable as it seems. Right now, it's in one of its most volatile moods. Its magnetic heart has flipped. Its storms are building. Its light is dancing across our skies in colors we barely understand. And we fragile beings on a small blue world are caught in its rhythm. The solar maximum has begun. Not just a phase in astronomy, but a reminder that even the most constant things in our universe are in motion. We live under a star that breathes, rages, sleeps, and awakens. And in its cycles, we may find the key to understanding not just the cosmos, but our own place within it. If you enjoyed this video about the sun and its magnetic flip, you'll definitely like this one about Mars and its big problem. Do you want to know what that is? You'll be shocked to find out. Don't miss it.